Yes. Hello. Are you able to hear me?
Yes, sir.
Yes, sir.
Yes.
Okay. Okay.
Yes, sir.
Okay. Okay. Nice. Nice.
Yes, sir.
Okay. This is an assignment class. Okay. So in this class we will do some more problems to clear your doubts. So about the rest, the other problem what I had given you, that is homework that I think you'll be able to do it. If you're not able to do it, that we'll discuss in the next session. Okay. So as far as the homework problem is concerned, and other problems are concerned, so let me give you some more problems. Let's see how you will be able to do it. So all the things that I'm teaching you are there in the notes, so don't need to worry from where we will get the notes and all. So the notes are custom made. Mhm. So just do this problem. Okay, this is very simple problem, so you people will be able to do it. Okay. Problem is a 10 ohm resistor, a 10 ohm resistor is in series with a parallel combination of, is in series with a parallel parallel combination of two resistor 14 ohm and 7 ohm. Okay, the current in the 7 ohm resistor is 4 amps. The current in 7 ohm resistor is 4 amps. Okay, determine, now it's asking you to determine. Okay, A is power dissipated in each resistor, power dissipated in each resistor, number one. Number two is voltage across each resistor. This is the B point, voltage across each resistor. And the number 3 point would be total power dissipated in the circuit. So please carry ahead. In circuit. So how do you go about this? So first of all, there is no diagram as such in this problem. So he has given, what he has done is that he has given simply, what he has done is he has given theoretically only. So you have to, by listening to this particular problem, so what you have to do is that you have to do this problem according to what? According to the question given, you have to do this problem. So how do you do this problem? What it is mentioning, you have to draw the circuit diagram first. So are you able to draw the circuit diagram? So there, if there is no circuit diagram, so what it states is that there is a circuit. Okay, so a 10 ohm resistor. So first of all, a 10 ohm resistor, if I draw like this, okay, this resistor is in series with a parallel combination of 2 and 7 ohm resistor. Okay, a parallel combination of two resistor, 14 ohm and 7 ohm. So this means it is in parallel combination with two resistors. One happens to be 14 ohm and other happens to be 7 ohm, like this. Okay, so this is 14 ohm, this is 7 ohm. This is the circuit. Okay, and what it says, the current in resistor of 7 ohm is 4 amps. So the current over here is 4 amps. Here the current flow is 4 amps. So now what the question is stating, you have to calculate the power dissipated in each resistor. So power dissipated so power dissipated in each resistor would be, like this is 7 ohm, So power here would be, if I take this as A point, okay, and this let be B point, this be C point. So power I in IA, it would be power dissipated here, that would be PA would be IA square into 7 ohms. At B point PB, that is IB square into 14 ohms. At C point it would be PC would be IC square into 14 ohms. So one thing is sure, that we need, nothing is given apart from this, okay? Only is
Sir,
given, yeah, tell me.
the series resistance is 10 ohm, no, sir?
Series resistance is 10 ohm, yes, 10 ohm. Today I'm on leave, actually I'm little ill. So that's why maybe some faltering is there. I'm not there in the college. So if some problem happens like this, so please bear with me. So this is 10 ohm, 14 ohms, 7 ohm, okay. So you have read the problem. So can you go ahead? Can you use some rules that I have taught you? See here. Can you see this network over here? See, when I was teaching you this rule like this, hmm, so current divider I told you, uh, like this is a parallel combination. So if I keep a resistance like this and then here parallel. So at this point B, if I name this point A, this point B, this point is B only na. So current entering this point B is what? This is the current. Suppose this is the current that is entering this point B. Suppose this is I. And what is leaving this B point? One current that is leaving is this. Another current that is leaving is this. So this is I1 and I2. So how can I write the current divider rule? I1, if this is R1 and R2, I know my I1 would be equal to R2 divided by R1 plus R1 plus R2 into I. Similarly, on similar grounds, my I2 would be equal to, tell me, my I2 would be equal to R1 divided by R1 plus R2 into I. So can I apply my current divider here? Can I see the circuit like this? Is the current entering the point BI, and this current is getting divided here? If this is my I1 and this is my I2, can anybody tell me what would be the current here? It would be I1 plus I2, which is nothing but equal to I. So this current over here is I. Just now I told you before, like finishing the class, like if this is a water, this is a tank, this is a 10-liter tank, okay, and this is for example 4 liters, or suppose this is a like 4 liters and 6 liters and all that thing. So you have to relate like that. So now you know that here my current is 4 amps. So I2 it is given, I2 it is given 4 amps. Now can't I calculate from this? The value of I2 is nothing but 14 divided by 14 plus 7 into I. Why? I'm applying a current divider rule. What I did? I applied current divider rule at 7 ohms. Okay. So I have applied current divider rule at 7 ohms. According to the current divider rule, if this is R1 and this is R2, so my I2 should be equal to R1. So that is R1 is 14 divided by R1 plus R2. R1 plus 14 plus 7 into my current I. I2 they have given. I2 they have given is 4. So 14 divided by 21 into I. So I can write 7 2s, 7 3s. So I would be 4 into 3, 12. 12 divided by 2, 6. So 6 amps. I can write my I is equal to 6 amps. So one thing I know, my I is 6 amps. So if here there is 4 amps, so what would be the value here? The value here would be, here what would be the value? Tell me. Here the value would be 2 amps. Okay, because this is 6 plus 2 amps. Now what it is saying is that power dissipated in each resistor. Can't I calculate PA? What would be the power dissipated IA? So I got the value of IA to be 2. And this value over here is PA would be, sorry, PA value I got it to be the value of this is 6 amps. So I can write here if I not need to calculate. So it would be 6 square into 10. You are correct. 10 ohm it should be. Okay. So 6 square into 10. So here if I want to calculate the power dissipated, so how much it would be? Tell me. Across this, it would be
360 watts.
6 square into, no. One thing is here. See, when I have to calculate at this particular point, it would be, we have to make sure, yes, we have to calculate properly. So properly calculation means what? At this juncture, so the power dissipated due to the total current would be because of the total resistance, not only because of the 10 ohm resistance. So this I is getting applied to 10 ohm as well as 14 and 7. So first of all, we have to calculate the net resistance. So we can see this is a series combination. 10 ohm and 14 and 7 parallel combination is series with 10 ohm. So 14 and 7, so R net would be equal to 10 ohm plus 14 in parallel with 7. So R net you have to calculate. So that R equivalent you have to multiply with I square. So you will get one value. Then as far as the voltage across the 7 ohm is concerned, so it's a straightforward 4 square into 7. As far as across the 14 ohm is concerned, so it is straightforward 2 square into 14. Across the 10 ohm resistance, if it is considered, it is straightforward 6 square into 10, which I just now did only across 10 ohm. For this power dissipated, so it will be 360 watts. Okay, and what else is asking? So please calculate the values and let me know, because this is an assignment, ELE assigned, so I want to see how you are responding. So calculate the values. Tell me.
Sir, for B, is it 56? I
For
mean, 14 ohm.
56 watt.
14 ohm, what is it? 56?
for 14 ohm.
Yes, sir.
Yes, sir. 56.
Yes,
Yeah.
sir, 56.
And for sir, this one?
7 ohm. 112 watts.
112 watts, yes,
Yes,
sir.
sir, 1 and
Yeah,
12
100.
watts.
Yes, sir.
Yeah. Actually, you have to calculate for for 14 ohm it would be 14 into 4, so that is 56.
56.
Okay, correct. For 7 ohm it would be
112.
100.
16 into 7.
Yeah. So 16 into 7, so 112 watts.
Yes, sir.
Yes, sir.
Okay.
Sir, we can use the basic tricks also in this question.
No, that we can use anywhere, but now we know the current divider. So see, earlier in the previous class you were absent.
No,
Very
sir, I
good.
was.
So there can we use basic tricks? We had to be see these basic tricks and all are okay, but when you are doing a complex circuitry now, you should be thorough with the new techniques that you are learning. Basic
Okay.
tricks can be applied anywhere, so it is not like that. So okay, so yeah, tell me about there are
10 ohm?
5, yeah, across the 10 ohm resistor. Okay, now you are present in the previous class.
Yes, sir, I was there. Actually, sir, there is 2G here, na? And my
Uh-huh.
Wi-Fi was disabled that day. That's why I was not able to talk or do something.
Okay. So this is like so you are able to do the problem. So now tell me the voltage across each resistor.
Voltage across this one. 7 ohm is
Sir.
28. 14 ohm is also 28.
And,
And for
and
this,
60 volts.
and 60, yes, sir.
What about the net voltage? What would be the net voltage?
Net voltage, sir. It's 1 minute, sir.
74. 88, sir.
88 volts, yes,
Yes, sir.
correct.
88 volts.
Okay, so on a similar grounds, I want to see that you people do one more problem, okay?
Yes, sir.
So, so that this is like you have to practice this, okay? So this is a problem number two. The total power consumed by the network shown below figure is 16 watts. Find the value. Find the value of R and total current. I will not explain. I'll wait. I'll see who does it. Then I'll explain. So this is the circuit. This is the current I. Okay. This is 4 ohm. This is resistor R. This is 4 ohm. This is resistor R. Then there's a combination of 2 ohm and 8 ohm. So this is 2 ohms. This is 8 ohms, and there's a battery that is interconnected, and the value of the battery happens to be 8 volts. It's plus minus 8 volts. Yeah, please do it. Yes, you do it, and let's see who does it first. So what you have to find is you have to find the value of I and R. Why it's taking so long? Hmm? Basic tricks you can use. By the time
Sir, R equal to 6 ohm.
R equal to 6 ohm, huh? Okay. I
2 amps.
2 amperes, sir.
I is 2 amps, huh? Yes. So this is very easy question. Basically, what is given is power is given. Power is given is 16 watts. So you can directly write your power is equal to what? Power is equal to V square into R. So like that you can do this problem. So why it took you so long to do this problem? Hmm?
Sir, it's done, sir.
Hmm?
Done, sir, done.
So R is equal to 4 ohms, not 6 ohms.
Yes, sir.
See here.
So,
See here, power is what basically? It's a very simple problem. V into I is power.
we into I.
Okay, so you know power is 16 watts. V is already mentioned, given 8 volts.
I is equal to from that one.
I is equal to 2 amps from that. And now you also know that P is equal to V square R. This is already given 16. V square is given 64. R would be equal to R is equal to 64 divided by 16, 4 ohms. So what was that big thing in that? Why it took so long? Okay, one more question from the VTU examination that I'm giving you. So this is a university exam question for your practice. Next page will do. Yeah. Find, I'll take, find the value of resistance. Find the value of resistance R as shown in figure, as shown in figure, so that the current drawn, am I recording the session?
Yes, sir.
Yeah, so that the current drawn from the source is 250 milliamps. All resistor value are shown in ohms. All resistor value are shown in ohms. So the number one thing is there is a voltage source plus minus 5 volt, and I'm connecting a resistance across this voltage source. One more resistance here, one more resistance here, and I connect a resistance like this. Okay, first of all, what I do before doing anything, I label it. I write this point A. So this is till here, it will remain A, including till here, because there is no element connected. Until unless there is, remember one thing, until and unless there is no element. And what is element? Element can be voltage source, it can be a resistance, it can be inductance, capacitance, any source, inductance, capacitance, it can be a diode also. If there is, means if only a wire is flowing, only until unless there is no element connected to the junction, the label point remains same. The label point remains same. So this is very important. So how to do a problem is not so here. Okay, A. Now you see over this point, this is B point. So this is also B point. Okay, this point over here is C. This is also C. See, there is no element connected. So we come to know that this R point, and now these values I'll keep 30 ohms. This is 40 ohms. This is again 40 ohms. Yeah, tell me.
Sir, could you please repeat the question and these things, sir, what you write in this head?
You are not able to see. Find the value of resistance R as shown in figure, so that the current drawn from the source is 250 milliamperes. All resistor value are shown in ohms.
Yes,
So
sir.
what you have to find is that find the value of R. So you have to find R. Okay, carry ahead. How do you do it? So first thing I told you how the circuit is exactly. Either you can rearrange the circuit. If you are seeing the circuit like I have drawn, you clearly see that AC and 40 are in parallel. Okay, so these resistances are in parallel, and now uh, between the point B and C. Okay, B A. If you see the triangle A, B, and C, if you clearly see the triangle A, B, and C, you can see the 40 ohm resistor is in series with this parallel combination of 40 and R. And now you see this 30 ohm resistor is between voltage source is connected to AB, and this 30 ohm resistor is also connected to AB. So that means this voltage source is in parallel with the 30 ohm resistor, and this 30 ohm resistor. Okay, now how can you write this 30 ohm resistor AB? Hmm? What is connected between? Can you rearrange this circuit? I mean, can you rearrange this circuit? And you know one thing for sure, that find the value of resistance R as shown in the figure, so that the current drawn from the source is 250 milliampere. So how do you write this circuit? We say that the 5 voltage source is generating a current of 250 milliamperes. So because of the 5 voltage source, here the current generation because of this is here, because of this it is 250 milliamps. Okay, so this is the question. First of all, what you have to do, you have to have a visualization skill. You have to rearrange this circuit. So in order to rearrange this circuit, see 30 ohm, see this, if we rearrange this circuit like between point AB there is 5 volt. So if I rearrange this circuit, I can write between point AB there is 5 volt. Okay, so this is plus, this is minus, this is 5 volt. Okay, this is point A and B. What else is there between point AB? So this point is A, this is B. So I can write there is again 30 ohm resistance is between point AB. Okay, because AB same point. Okay, now if the 30 ohm resistor is between point AB and this point AB, the current entering this point AB happens to be how much? The current entering this point AB happens to be around 250 milliamperes. So this happens to be 250 milliamperes. This 250 milliamperes. Now one more thing is that now you have to go again. Now this AB, here, this 40 ohm is connected to point what? Connected to point B. And another 40 ohm is connected between BC. Huh? BC. But if I want to reduce this network, if I want to reduce this network, if I can reduce this network, I can say that this 40 ohm is in parallel with R. 40 ohm is parallel with R. This 40 ohm is parallel with R. I'm talking about this and this because these are connected between AC. Aren't they connected between these 2 points, A and C, A and C? So this is in parallel. And now this 40 and R combination is in series with what? There is a simple node that is connected over here, C point. It is in series with, it is in series with what? This 40 ohm resistor. So I can draw this is in series with this 40 ohm resistor. So when I'm reducing this network to this point, so which is again connected to point. This is A, this is point till here it is A. This is Hello? Yeah. Okay.
Yes, sir.
This one.
Yes, sir.
Yes, sir.
Was this disconnected?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, sorry. So that's what I was wondering. Nobody is answering. Yeah. I'm sorry. I did so much till now. Okay. From yeah. Okay. Okay. No problem. Till this figure construction, you understood how I have drawn this figure.
No, sir. No, sir. You were
No,
understanding
sir.
this
It
one.
was
Was disconnected, huh?
No, sir.
This figure you understood how I have drawn. Okay,
No,
wait,
sir.
No, sir.
wait.
No,
I'll
sir.
see how much I have done.
Sir, R is 40 ohms, sir.
R is 40 ohms. Yes, correct. I'll explain to you who have not this figure at least. Okay, no problem. See, main thing is this figure. Okay. Actually, some of you might be having the notes and all. You can tell from the notes whether it is 40 or something like that. But looking at the notes is not the main thing. Okay, I could have done other problems also. There are thousands of problems, but time and again you people ask for everything. We cannot construct notes. Okay, so earlier I was doing different type of any problem can appear. So notes problems why I'm solving is because it becomes easy for you to refer and go back. But for understanding purpose, how they have made in the notes we cannot write. See here, this is the network. Okay, so what I told you in the very beginning. So here from this I can see that this 5 volt. Okay, this 5 volt is in this 5 volt here. A and B and A and B. Between 5 volts, A and B, 5 volt and 30 ohm is connected. So you can see this between A and B. So here 5 volts is connected, and here why this is happening? That's what I'm getting irritated. Okay. Suppose this is my 5 volt, and the resistance over here. Okay. Between these points, this is 30 ohm and this is 5 volt. This point A and B. Suppose if I reduce this network, so this network will become, see, bit 40 and R is in parallel, because 40 and R, why they are in parallel? Because they are connected between A and C, A and C, and there is one series combination of C over there, and this is in series with 40 ohm. Now if I reduce this network, total this network I reduce, suppose till here I reduce this network till here. So again, if I reduce this network, this I will reach at this 40 R and 40. So this 40 and R parallel combination of 41 and would be connected to A, and after this reduction of this series network, another point would be connected to B. You are getting my point? So again, this 40 and parallel with R and 40 combination is connected between points A and B. So that means this is in parallel with this 40 parallel with R, and this parallel is connected like this. This is 40, this is R, this is 40. Suppose this current is 250 milliamps. 250 milliamps, and now this 250 milliamps is getting divided here into I1 at this juncture. Okay, it's getting divided into I1 and this point I2. So if I want to calculate the value of I1, so I know across this what is across 30 ohm volt, 30 ohm, what is the voltage across this? Same, because it's parallel. So this voltage 30 into I1 would be equal to 5 volts. So I can calculate the value of I1, that would be 5 by 30. So what is this value of 5 by 30? Please tell me. Tell me the value. Hello? Hello?
Yes,
Yeah,
sir.
tell me. It's connected.
Yes, sir.
Yeah.
Yes,
Tell me
sir.
the
Yes,
Yes,
sir.
yeah, again, if it is like 0.166 amps. Okay.
0.16.
Okay. Now, similarly, what would be the value of I2? I2 value is 250 minus I1. So 250 into 10 power minus 3, because it's in milliamperes, minus of 0.166. So this happens to be around 0.08334 amps. So this is 0.08334 amps. So now what is the value of V across this? Across this also V will remain same. Now V will remain 5 volts only because it's in parallel. So this is I2 into R. So I2 value you calculated. Now you want to get the value of R. So what is I2? This 5 volt would be equal to 0.08334, and R how, and this would be net combination. What is the net combination? Net combination is 40 plus 40R, 40 plus R. If you solve this network, you will get the value of R. Okay, if you solve this equation. So if you are solving the equation, you will get around the value of R from here. So please remember this point is very important. Any doubts? Yeah, here is this rubber over here. Yeah. So what will be the value of R? So the value of R would be equal to, this is around 5. So 0.08334, 40R, 40 plus R plus 40, and this you can write like this: 40R, 40 plus R plus 40. And if you take this approximate, this would be 60. So again you can write 20, 40 plus R would be equal to 40R, or you can write 20R is equal to 800. So you get the value of R to be 40. Okay, so this was one question that has appeared recently in December 2019. Okay, December 2019, this question has appeared in VTU exam, this problem. Let's see one more problem of VTU examination so that you will be able to do. So this problem was also very simple, but the circuit arrangement was like that you have to understand. Okay, so now this has appeared in June 2017 or 13, some year it has appeared. So in parallel, this is a VTO problem. Okay, 13 or 17 something. In the parallel arrangement of resistor, in the parallel arrangement of resistor shown current flowing 8 ohm resistor, current flowing 8 ohm resistor is 2.5 amps. Now the question is, find current in other resistors. Okay, so resistors, one thing is that the equivalent resistance. This is very simple. I think all of you should be able to do. All of you means all of you, not few of you. Few of you are doing all the problems that I am giving, so I'm okay with that. So there are people who are following, but I want all of you to do this. See, if you apply the concepts that I am giving you now, then there is not difficulty in solving any problem. But if you are mugging, going for some substandard books, then a lot of confusion will arise. Avoid BL Thareja, VK Mittal Mehta or something like that is there. No, those books are not good. They are commercial books. They are not written by professionals who are in the field. So there are so many mistakes there and you'll get confused. See, this is 8 ohms. This is X ohms, 40 ohms and 25 ohms. See, now this is like, how do you do? First of all, you have got, see, this is a parallel arrangement. Okay, and what it states is that current flowing in 8 ohm resistor is 2.5 ohm. So the current in 8 ohm resistor, it is mentioning is 2.5 ampere. So here, if the current flow, if I have to check it, here it is 2.5 amps. Okay, and the equivalent resistance. So number one thing is that if you see this combination is in parallel, So if this is 2.5 into 8, so the volt, if there is voltage V here, V would be same, V would be same, V would be same. So if you are able to get the voltage, then you are able to get the current through all the networks. So please do it and get me the values, all of you. Hmm?
Sir, 100 ohms.
Hmm?
100 ohms.
So which value you have calculated? Equivalent resistance, huh?
Sir, X.
Wait, the X value. Okay, let others also do. Yeah, Srishti, you do. Srishti, what is the value
Doing,
you want?
sir.
Do Aram se, I'm waiting. No problem.
Yes, sir.
Do it. Likhita, you are doing?
And
Yes, sir. Trying, sir.
Trying any difficulty you are getting?
No, sir,
Trying.
not much.
Okay, okay. Who answered? What's your name? Who answered 100 ohms?
Sir, I.
No, what's your name? That's what I'm
Sir,
asking.
Krishnakant.
Krishnakant Gupta, huh?
Yes, sir.
Okay. Yeah, Khan. What is the value?
Yes, sir. Doing some 1 minute, sir. For this 40 ohm, it's 2 of I.
No, no, X for X I'm asking.
For X, sir, witness, sir.
Sir, it's 100 ohms.
Hmm.
1 minute. Sir.
Hmm.
100 ohms, sir.
Yeah, any other. What is the R equivalent value? Girls are not doing. Why?
Sir, I did, sir.
Usually, what's your name?
Sir, 5 ohms, sir. R equivalent.
Sir, R equivalent is 5 ohms, sir.
R equivalent is for Mohammad Zaid. Mohammad
Sir,
Zaid,
X equal to 100 ohm and
Yes,
I
sir.
for X is equal to 0.2 ampere.
you are doing or not? Mohammad Zaid? Zaid? I think he's not doing. Yeah,
Yes, sir. R equivalent 5 ohms.
Now for those people by now you should do, because see, it is not, we don't have entire day available for doing a problem. So in engineering you have to pick up Likhita, Lavanya, everybody. I'm telling you, Srishti, you have to pick up your speed. See, I'm putting all the videos also there on Drive, is also there on Link, is also there, or even though in YouTube also I'm putting. But apart from that, teaching also. But by now, like within 5 minutes you should do. Okay, so this is not that big a problem. First of all, voltage across 8 ohm resistor. What is the voltage across 8 ohm resistor? See, voltage across, I told you to calculate this V. First thing is that 2.5 into 8 is this value. So 2.5 into 8, so you'll get the value. So this would be around 20 volts. So you know that this is 20 volts. So now I across I 40 across this would be across 40 would be across how much? I 40 into 40 would be 20. So you can calculate the I 40 value. So this would be 20 divided by 40. Similarly, I 25 value would be 20 divided by 25. Now you want the value of Ix. Okay. Ix value is what? 20 divided by x. You don't know the value of x. That is the problem, that you don't know. So you have to calculate the value of x.
Yes, sir.
So if you clearly see here, there is a 4 ampere current entering here. Okay, and it is getting divided. It is getting divided into I40 plus Ix plus I25 plus I8. Okay, so I8 value we know. So I8 value So Ix value we have to calculate, that is 4 minus of I8 minus of Ix, and what else is there? Minus of I40 and minus of I25. So you will get not minus of Ix, minus of I25. Ix value you have to find. Is it okay? So Ix value you have to find. So Ix value would be 4 minus I8 minus I25 minus I40. So from there you get the value of Ix. So this is first of all, this is 4, and I8 value you calculated. How much was the I8 value? Tell me. I8 value is 0 minus 2.5. I25 value is 20 divided by 25. So 20 divided by 25, 5 5s are 5 4s are. So this is 0.2.
0.8.
Okay, minus this is another value is here. I40. Yeah, tell me.
Sir, 0.8, sir.
0.8 ampere, sir.
So Ix value is 0.8. No, we know that this is 0.8. Okay, now everybody will tell.
Sir, R equivalence 5 ohm.
0.8 amperes. So you calculated the Ix value. Now Ix value is there known 0.8 amperes. So this value is substituted 20 by X. So X will go here. X will become 20 divided by 0.8. 0.8 is 8 into 10. So this
Yes,
becomes 4 2s are 4 5s are. So 50 divided. So how you are getting this value? Uh, 100 20 by
Sir,
X.
I got Ix is equal to 0.2.
Ix,
Yes,
Ix,
sir.
Yes, sir. Yes, sir.
Ix is equal to wait. Let me see. 2.7. But
Sir,
yeah,
4 by 5 is equal to 0.8, sir. I of 25.
so this is
yes, sir.
4
20
by
upon 25 equals to
To be
0.8 of
20 by 25, sir.
the last
20 by the last one
In
is 0.
Ix is, yes, sir. Ix is
Yeah,
equal to 4
yeah, yeah,
minus 2.5 minus
yeah, yeah,
0.8.
yeah. It is Ix is equal to 4 minus 2.5 minus of zero point 0.5 and minus of zero point 0.8. Okay, so this will become, yeah, correct. Wait 1 second. 1 second.
सर R equivalence 5 आ रहा है.
Hello, yeah.
uh,
Tell me, yes. So this is equal to, actually a little bit of favor is there. So Ix is equal to zero point 0.2 amps. Yes. So
0.2
this
and
is, yeah, this will be
20
0.
upon
0.2. Yeah.
0.2 equals to
So
100.
this is zero point 0.2 amps. So this Ix, this is zero point 0.2 is equal to 20 by X. So this is equal to 100 ohms. And R net would be equal to, you know that this is 100 ohms. So R
5.
net is R net would be equal to 5. Okay, so this is a parallel combination. You can write 1 by 8 plus 1 by 100 plus 1 by 40 plus 1 by 25. So it's 12:30 now. Huh? Now you are having any other class?
No, sir, it's lunch break. Sir.
No, it's
Okay.
lunch break, sir.
So okay, I will give you one lunch break means you are there in the home only. So what lunch break you need? Okay, one question I'll give. Huh? Please do this question. Try to do this question. Okay.
Okay,
Uh,
sir.
one nimisha. So I'll put in the WhatsApp group. Okay. So yeah, please do this question. Yeah. No, I'll one nimisha wait man. Yeah. This is like this. Yeah. This is I1. This is I2. This is I3. This is 100 volts. Okay. This is 10 ohms. This is 50 volts. This is again 2 ohms. This is 50 volts, and this is 2 and this is 3 ohms. Okay, so all the values I mentioned. So using KVL, determine the value of current. Okay, so Ix and Iy. So there is a current like this, Ix, and there's a current direction of the current I'm showing Iy. So determine the value of Ix and Iy. Determine the value of Ix and Iy. Okay, so you have to using KVL.
Sir,
So this is the question. Yeah, tell me.
sir, in first loop, the resistance value is not mentioned.
Resistance value is not 5 ohms. 5 ohms. Okay,
Hmm.
5 ohms. Anywhere else, if I'm 5, 10 ohms, 5 ohms, 2 ohms, 2 ohms, 3 ohms. 2 ohms, 2 ohms, 3 ohms. So you do this question. So we'll wind up the class. I'll stop recording over here. Thank you very much.
Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Thank you.